Everybody, we got Crash Bandicoot going right there. So we are starting up. Today we're going to talk a lot about, I guess, the take home a little bit. Not too much, but I want to give like the biggest advice I can give. What's up, Jake? Good to see you here. And kind of about the final. So the take home today will be talked about. The final will be talked about today. And I guess one of the biggest things is please fill out the TN voice. I want to say something right here. People were asking about the extra credit and everything. Our goal with grades this semester is to really be as nice as possible. And you might say, well, Brian, why weren't you as nice as possible every other semester? There's been a lot of circumstances this semester. A lot of interesting, crazy things happened. Coronavirus. Yeah, we know what's going on. Probably just got the whole video flagged. Oh no, we're off YouTube now. And I'm sure everyone can hear and see me. We had that one time, and now I'm always like, no one can hear and see me. How are we doing in the chat? Who's here? Can everyone hear and see me? Are we live? I look at the volume, and it's a little bit low. I watch the broadcast afterwards sometimes to check out the volume. So I turn up the volume a little bit. Helps when I'm closer to the microphone. Can everyone hear and see me? No one's saying anything in the chat. You can. Awesome. You can hear just fine. Awesome. Good deal. So I always try to get a little bit closer to the microphone. You are live. Good. It's when everyone's quiet, I'm like, oh no. We did it one time. Um, you will be knitting this right here. So it's going to be graded by the graders like an assignment. But the way the grading is, and I think we agreed on this, I'm always just, there's so many things going on right now. We're making a Stat 201 comprehensive exam for exam 1. We're making a Stat 201 exam 3. We've got this right here. And so there's like all these different balls in the air. We're just juggling. I could juggle them right here. What? I've only got 2. So we can juggle 2 in one hand. It's very hard to do this while sitting. I'm going to hit the computer now. So we got all these balls in the air right here. This is one-handed juggling. I hit the screen, but it's all right. So there we go. We got all these balls in the air. I don't know where the third one is, so it's hard to juggle like this when you're sitting. Hey, what's up, Tyler? So, and I thank you to Dr. Hilifu made the take-home primarily. So thank you very much for all his hard work on that. I'm working on your guys' online test, which you will be taking next week. It'll be open for 2 days. We're going to have it on the day it's due, I believe, and then the next day. Please don't wait till the night all these things are due to do them. Try to find a time when you know you have good internet, when everything's working, lest you wait till the exact moment it's due, and then you've got like 1 hour to do it or 2 hours to do it. Don't wait. Has anyone looked at the take-home yet and tried it? Has anyone looked at the take-home yet and tried it? Has anyone looked at that? I know at least one person. I saw one person in the chat I know who has, because they emailed me, and hopefully they can tell in the chat. Yep, not yet. Has anyone we know? Yep, you've looked at it, Will? Yep, it's out. It should be out. It's out there in the assignments. I've downloaded it yet, and I opened it but didn't look at it. Starting tonight. Good stuff. It's not that bad. A lot of the code, this is a huge hint, is basically repeating it. So Lillian, let me make Lillian a mod right here. So, and once again, please do not post anything to anybody about it. Please do not communicate between people about it. Don't go to someone and be like, hey, how do you do this question? Can you give me some help here? I'm really stuck on this. Don't do that. Don't do that. Don't do that. Please. Remember, I always talk about this. We had that big incident that caused coding night, and it's just something we don't like dealing with. It makes our lives a lot less fun, and it's much better to get just not the best of grades on it than to start reaching out. And we do ask that you guys kind of tell us if things are happening like that. I mean, I know it's not fun to like tell people stuff, but we want this. Our whole goal with this is that we want to assess your ability to make models and understand models and produce output and know what's going on with all of these algorithms. So the coding stuff is meant to be like, can you actually write the code? So that's the point of the coding night. And you're basically getting what you would get on coding night, is just make a bunch of models. And if you know the pattern to make them, they're not that bad. And that's one of the really great things about Carrot. And I'm also going to mention another thing here in a second. So you guys be like, Brian, didn't mention the workshop. I sent out an email about it. But who has found the Carrot format of writing models pretty easy to deal with? Like, who, with writing your models, when you write your Carrot format of a model, and you only have to change very, very little of it to get it to run, who has found this Carrot formatting of writing models where you really only have to change either your fit control or your tuning grid of what you tune the models through? So once everything's set up, it's easier. Yeah, it's this is why they made this. This is why it's part of Tidyverse and everything. And this leads us into our. It's much easier. Yeah, the coding on it is so easy. It makes it too easy at times. We think if everyone get errors, would it be able to comment it out? Yes, exactly. Do comment it out, Leah. Great question. David says super simple or much easier. Yeah, it's so funny because And that's what people have told me about the end of the course. They're like, wait, you taught us all these coding skills to just like copy paste code. And I'm like, well, I mean, sometimes it is that easy. Sometimes someone's already written all the code you need. So, why write all our own code when someone's already done it? Now, we should know how to make adjustments. We should know what everything does. But imagine, it's so funny. I was showing some of this stuff to like 201, and they're like, oh, you're such a genius. And I'm like, well, I mean, I've worked on it for a while. Do we need to download the purchase CSV off the assignment? It's not working for me. You might need to do that. Make sure you have that. So get the purchase CSV if it's not working, and email me if it's not working, and we'll make sure it's working. It looks like you do need to get that. You, Calzone, you're awesome. Calzone, so good to have you. But and so you might think all my students are geniuses too. So Calzone has said that all of you are geniuses also. If you think this is easy, you're a genius. I would counter that, and I would say it's because you've worked really hard at this. Because the day you entered into 320, if I gave you this whole thing of code, what would you guys have thought on the first day you went to 320, where we'd never seen coding? Some of you had, but for those who had never seen coding or very, very never done much coding, if you had seen all this code right here, would you have just been like, "What in the world is going on with this?" You would have died. I like that. And Caleb, you're doing great. What slide decks? Oh, we're using support vector machine right now. I'm changing. And now you look at it and you're like, it's not that bad. It's just I'm changing collateral. So it's so good to Calzone. You should see how many points you have, Calzone. No one's been checking their points today. It should be working. I'm interested to see how many points Calzone has. He's fan favorite. Always here. Complete brain shut down without 320 knowledge. Yeah, we've got points now in here that it should be working. But you can do $points. Watch it not be working today. Let me make sure it's. Yes, it is working. Yeah, so you can see how many points you have. The more you talk in chat, the more points you get. So you can see everyone's checking their points right now. It's every 5-minute intervals you talk, you get points. And it's only recorded on times when I'm doing public streams, which I think Calzone's got 180, which is pretty high. Calzone, you notice. And so we're right up there with some people who've been in chat a whole bunch. You're tied with Ivy right there. So the more you talk, the more points you get. So it's a pretty fun feature that we have that you can see. You guys are awesome in chat. So Dave was quite happy about his points, so it seems. But I really like this feature, and we're going to start doing more with it. I can do polls and stuff with this. But I think the biggest thing to recognize is that if you are able to understand this code, one, that's pretty impressive. I know we're saying like, oh, this is easy code. We got we've got such an easy code right here. It's just, it's just training the model via the carrot package. We're predicting quality based on all the X variables. That's what the dot means. We're using the data set EX6wine. The method we're using to do this in the carrot package is the neural net method. The training control is being set by the fit control, which is being set to predict accuracy, because this is how we set it up to predict accuracy, which means quality is a categorical variable. Verbose equal false turns off a lot of output, so does trace equals false. Line out equals false is because we're doing a categorical variable. If it was quantitative, line out would need to be true. Pre-proc center scale, someone gets maxed out on extra credit. This is a 201 topic. Pre-proc center scale is going to turn everything into what's for these. Pre-proc, who's going to be the first person. Pre-proc center scale is going to turn everything into what's. Going to turn everything into what's. Who knows? There we go. Andrew got it. Z-scores. Now, we do think of the normal curve with Z-scores, but watch out. It will not make the data normal. It'll turn them into Z-scores, which should be on the normal curve, but it won't transform the data. Transformations to data must happen outside of it. We've got things to transform the data. So if you do feel that your data is not normal, you could do like a log 10 transformation and all that good stuff right there. So we do have ways to transform the data if it's not normal, but pre-proc center scale turns things into Z-scores. I just want to put that straight as a test question. Good to see you, Shay, and everyone. So I feel like, Shay, were you in the class last semester? Or wait, I just feel like all of a sudden I'm like, no, you're in this class this semester, but you were in 320 with me last semester. Is that correct, Shay? Correct me if I'm wrong on that. You're in my stats mini master. That's what it is. I see so many names. Thank you. So good to see you, Shay. So yeah, are you in 474 right now? And you're more than welcome to stay. You're in this class now. Yeah. Awesome. Gosh, there's so many names. It's like I'm like yes. Yeah. No, it's so good. Yeah, I love it. I'm like I know that name. So awesome. Plus you're a mod. But once again, we have to know what all this code does right here. This right here, just knowing what this little bit of code does, this goes and gets the results because it stores as a list inside of neural net. That's just neural net right there is what we called it. And then we're going inside of the list to get the results. This is a list of stuff. Then we're going into the element of results, and then results is a data frame of results. So then we're going to the row in the data frame that has the best tune, and we're taking the row names, which is the position of it. We could do like whiches and stuff. We could do like which equals best tune and all this crazy stuff. But this code works right here. You'll see me copy paste it a lot. But this is your best model right here. Now, I do want to point out one thing. When you're plotting stuff, this is a huge hint. Be ready for Andrew's timestamps. Make sure to put the timestamps in at the end of the video, like in the comments down below. The variable imp code can be used to show you variable importance, and then use plot. I would do a horizontal plot, hint, hint, hints. These are huge hints on plotting your variable importance. You pretty much just want to run variable imp, var imp on the model. This is a huge hint of some meme about this earlier, and I try to tell everyone the same hints. But you want to run var imp, but nest that inside of a plot, and then maybe think about, putting it horizontal or stuff like that. But does that make sense to everybody right there? You can run var imp, and that'll give you the variable importance, and you can plot those and do them horizontal. So that's how to plot your variable importance. I try to drop the same hints for everybody, but can it show us? I don't want to write the code out exactly. I want you guys to write it out. I don't want it, because if I write it, then you'll see it. And so I want the take home to be as kind of you guys doing it as possible. But yep, and so you got small hints. And I like that those small hints are allowed right here. But it'll actually be a reverse of the nesting. Does that make sense, Andrew? Because I think you get what I'm saying. You don't want to do var imp plot, because that would try to get the var imp of the plot. You want to put var imp inside of plot, because that'll plot the variable importance. Does that make sense? Does everyone kind of clear on that? It'll be the var imp will be nested inside of plot, because you're going to get the var imps and then you're going to plot them, the variable importance. That's what var imp stands for. Who's on track with me on that right there? Maybe someone's written it out already. Don't write it in the chat, but var imp is nested inside of plot, and then you can do the features inside of plot. So the first argument of plot is what do you want to plot, and you want to plot the variable importance. Does that make sense? Like, I can write it. Let me bring up R. The first argument inside of plot is what are you plotting, and so let's go right here. We got all the code open. So if you go to plot and you do like 1 through 5, let's do 5 through 1. So you'll get a plot right here just like this, and we should be able to do, you can change the way it looks, but you'll get a slightly different plot. But the first thing of what you're doing right here, so you could just call this X, and then you could store something into X. Everyone's going to do that now. If I do that, everyone's going to code like I code. But, it's just what do you want to plot, and then whatever you want to plot. Who thinks this makes sense? Is this our last exam, or we'll have a conceptual one as well? You will have a conceptual one. So it's going to be a lot of true, false, multiple choice, matching, and it'll be on the day of the conceptual exam. We're going to have it open for 2 days. I think what it is I looked at the schedule, and you guys have it on one day, and the other sections have it on another day. So we're going to have it over those 2 days. So let me double check, but it will be open the day of your final. So the 474 final will be open the whole day of your final, and it'll be open an additional day. I tell you what, let's go look at that right now. Why not? Because I've got access to that information. So, because we had a meeting about this, and I've had so many meetings. My brain's like, okay, which class is on which thing here and which? And I've got the notes on my other computer. Okay, so we're pulling up the schedule right here, and let's just talk about the final real quick, make sure everyone's on track on that. So here we go. If you notice right here, let me pull back up my monitors and see what everyone's saying. Calzone, so glad that you enjoy our class and have fun. It is in lockdown browser. Please contact us if there's any issues. Please tell us immediately if things are not working. Do not wait till the last hour it's due. Do not wait till the last hour to do the take home. I know things are busy, but we try to give enough time for the take home as possible. We think that the take home should take 2 to 5 hours. Obviously 2 hours if you're just like, I don't know, it might take me 2 hours. It might take me 3 hours. But 2 to 5 hours is what I would expect someone to work on the take home for. It's like another assignment. So if it's open for 2 days, does that mean we have 2 days to take it, or we still have limited to like an hour or two? So Shay, great question right there. You basically have 2 days to start it, and then you will have a time frame of like, I think we said 2 hours to take it, because it's a 2-hour exam already. So you have the full time frame of these days right here if you notice, we have the 4 sections, which are on 2 different days. So we're keeping it over these 2 days right here. So you can take it on either of these 2 days. You can take it April 30th, which is 1 week from today. I got to finish it this weekend. So you can take it, and please tell us if there's any issues. If you think something's weird, you won't see your answers right away. We'll probably wait till like May 2nd to show answers. You will get to see the answers for this. And I talked to Vu last night. We're trying to figure out how he can get me the exams. Obviously, Brian has had as limited exposure to the outside world as he can. So Vu and I are working on a plan. And once again, when it comes to grades, we are going to be as forgiving as possible. Many of you might know we are going to take the higher of your 2 coding night exams for your higher coding night exam grade. So if you see here, we've got coding night exam 1 was worth 12.5% of your grade. Coding night exam 2 is worth 7.5. So if you did not do well on coding night 1, why is it super important? I want someone to say it in the chat. Why is it super important what Brian just said to do well on coding night 2, which is the take home, which you will have more time for? Why is it so important to do well on coding night 2? Why is it? Because it'll outweigh the other, because it'll be the higher grade weighted. It'll take the 12.5. It weighs more. Exactly. So if you're looking for a great way to improve your grade right now, if you're like, oh, I didn't do so well on my first coding night, I got like a 40 or a 60 or a 70, or 80, I want to make higher than that. Who knows? I mean, 80, some people are like, oh, I got an 80. That's all right. And the way, I wish I could pull up the email, but I don't want to pull up emails and everything right now. Oh yeah, this is all of our topics right here, Calzone. And feel free, keep asking those questions. These are the topics we've covered in this class, so you can ask them anything you want about tree-based model with partitioning. You can ask them. We just did support vector machine. We didn't get down to this right here. We did neural nets and deep learning, but we didn't do discretization and ensembling models. Yep. So all this good stuff right here. And so the first coding night, yep, it was pretty rough. It was pretty tough, and if you do really well on this one, it'll outweigh it. So here's what I said. My key to the graders is, one, they're going to be busy with their stuff, and that they're still graders, obviously. But to help them with grading, so I don't have it in front of me right now. I feel like I should go grab my computer and just look at it. Off the top of my mind, a 100 was if somebody completely understands the concepts and there's few to no errors in what they've submitted. Like, it means like you have superior knowledge. Does that make sense? And then a 90 has strong knowledge, but there are some errors in what they've done. Like, they're supposed to read through your report and then assess a grade to it, like an overall grade to it. So 100 is like superior knowledge. So we might see some 100s, and maybe they can give 95s. I'm okay if they kind of go between. It's a little subjective, and we do want to see if the graders are being even across. So we can do tests to see if the graders were similar in their grading. Then a 90 was like strong knowledge, but there are some errors, like you maybe did the models incorrectly, or it's not clear when you interpret them. 80 is like has multiple errors, and there appear to be gaps in knowledge. 70 is strong gaps in knowledge that show that there's areas this person would need to improve on. And then I think I said 50, and I think 50 was turned in the majority of the take home, but did not, like, there was major gaps. 20 was like turned in something that can be, perceived as a submission to the take home, and then 0. And I didn't want it to be like someone just turns it in and gets a 20. You actually have to put in some work to get a 20. So you actually have to like attempt some things, and you actually have to, no one wants to get a 20, I think, but I don't want someone to be like, oh, I turned in the take home blank and I got a 20. No, you'd have to do some work to get the 20. So, all this good stuff right here. Does that make sense on the grading and why doing the take home is even more important than ever? The take home is super duper duper important. Super duper. So with the take home right there, and everyone understands, with the conceptual exam will be out next week on Thursday and Friday. Today's days are going away. I don't know what day it is. So the take home will be out Thursday and Friday next week. Now I want to point to one more big important thing. So let me go to the announcement right here and show this. Maybe I can drop it in the chat. Has anybody? We got 2 more big announcements before talking everything today. Calzone, what in data mining interests you? Have you done any data mining, Calzone? I don't know if you want to say what you're studying or what you're doing, but I don't know how. Oh wait, that's the announcement there. Let's go to the other announcement. That's my send. Welcome. Here we go. So this announcement is an announcement everyone should have gotten right here. I think this is going to be super fascinating. I know everyone's really busy right now, and this is a rather long workshop. It goes from 8 a.m. I put 8:30 in my calendar. I need to fix that. I think it goes till 4:30 in the afternoon. Obviously, even if you can come for a little bit, I think this would be very important. Bob Munchin is basically our technology guy when it comes to the latest and greatest in coding and with software and everything. He is on the cutting edge of it. If I am correct, he is also the person who tracks what companies use what software. So the reason we are using R is because Bob Munchin has a website where he tracks I think it is like Monster and all the other companies and all the hiring places and the coding skills that they're putting in to their requests for applicants. And so he makes sure that what people are asking, we're actually delivering on. So if all of a sudden we saw that R went like this and R just plummeted, and all of a sudden Python spikes, which I mean Python's very good. If you know Python, that's a huge plus. Knowing R, knowing Python, knowing SAS, knowing SQL, knowing Hadoop, knowing Tableau, knowing all of these things are all pluses, but we understand that you can't become an expert in all of them. So, I mean, immediately, you could eventually, but usually someone has like a primary. It's like people who speak 5 languages, usually they have like two they're excellent at, or like their first one and their second one, their third one, their fourth one, their fifth one. But there's people who speak 5 languages amazingly. So, yeah. But the same thing is true for coding. Like myself, I'm primarily R. I've done some HTML, I've done some very little Python. Started out writing just simple things in DOS, which is not really coding, but it's still writing code and communicating with the computer. But the more you do, the better you get. So has anyone signed up for this workshop yet? Has anybody jumped into this workshop yet? Has anyone given it a shot? If not, check out the announcement. I think I can put the link inside of here. Let me go grab this link. Copy link address. Can I put it in the chat? Well, yes, it hyperlinked. So check that out right there. This is why I want to point this out. Because the last time I went to a meeting with Bob Munchin, he pretty much convinced me that Stat 201, either a year from now or 2 years from now, will be using R, and it will be using a GUI of R, which is a graphical user interface. Has anyone checked out this workshop, or I plan on joining for a while? Yeah, you go through here, you sign up. There's tons of seats open. It's completely free. Yeah, if you can come in for a little bit, I'm sure they'd be fine with that. If you're like, oh, I have class, or I have work, or I have things I have to do. But if I can ever encourage you guys to do something, is to continue to learn. I know you're not going to get anything by going to this workshop, as in like a grade, but this is super important to just like I know I'm going to learn a lot, and so you'll be in there with probably me and Dr. Petrie, Dr. Zaretsky maybe. But this is and Bob Munchin does some really cool stuff. So good stuff. So now that we've got all of our announcements out of the way, and what's going on, just one of these days I'll get a haircut. It's going crazy. Just I'll have my beard get as long as my hair. Just look. Feel like what the heck happened to you, Brian? You're like quarantine, COVID-19. But any other questions about what's going on with the world today? I'm trying to think if there's any other major things. We're already 20 minutes into class. Wow. We've talked about the take home a little bit. We've talked about the conceptual exam, and we've talked about our announcements. One last thing I want to say is the TN voice. I'll probably send out a reminder about it. I'm not doing extra credit on this semester because we're literally going to be putting in as much extra credit as we can. Let me check with Dr. Hulafu and Dr. Liu. So I'll check with them. I'll talk to them. I'll send them some emails later tonight. So maybe this weekend I might be like, hey, do the TN voice. Quick, do it. Because you guys know I usually do something for the class. But I'll talk to them. I'll see what's happening, and we'll do it because I can't make decisions unilaterally. So do we get a cheat sheet on the conceptual final? You should. Don't quote me on that yet. You should. You should. We've always done that. And so I think if you can obviously take good enough notes, and you should hold up your cheat sheet beforehand, I think you should. I think that's fair enough. And so it's fun writing this conceptual final. I've never written one like this. And we're going to try and make it as fair as possible. The conceptual exam will be on Thursday and Friday of next week. So the conceptual exam is Thursday, Friday, and next week. Oh my gosh, got too many look at all those Word documents. That's all yesterday. That's 201. So here's when it is. It'll be open all day those days. And I'm pretty certain we'll do the cheat sheet again. And then I'm just going to try to, and I will say this, please realize that whatever grade you get on the conceptual, if for some reason the class average is a 40, do you think we're going to let the class average be a 40? Like, let's say the class average on the conceptual is a 40. Do you think that we're just going to be like, 40 class average, whatever? Because this is our first time delivering a final in 474 this way. So it'll close at 11:59. You're right, and David's right also. It'll close on Friday night. So make sure, here's the link to workshop if anyone wants. Oh, you're awesome, Andrew. The best. And so Aaron wants a curve. We would curve. Now, if the average is an 80, do you think we're going to curve? If the average is an 80, do you think we'll... just waiting for the people like, yeah, of course. Why not? Just bring it to a 90. We'll just give everyone A's. No, if the average is really high, we won't curve. So David says yes. So we will, so sorry, only for E. Good to see you, Spencer. So we will, coding night would have a curve if all of a sudden, this coding night is less likely to have a curve. Usually flatten the curve. Coding night is way less likely to have a curve. It is possible, but I highly doubt it. I would say the possibility of a coding night curve is 2%. The possibility of a exam curve is more like 30%. I don't think it'll happen. I think the grades will be good enough. If it's like a 75, we'll be fine with that. So don't expect a curve on either. Really don't expect it on coding night. Like, don't be like, the average will be a 50 and they'll curve it up. I think people will do pretty well on coding night. For those who have checked out coding night, I think if people have downloaded it, how similar is it step by step by step by step? I don't want you to don't give away any code, obviously, but it's not, there's a lot of copy paste. There's a lot of copy paste. Remember that. And so you just have to know what to change and what to do. And it makes you look really smart because you're like, whoa, I wrote all this code. But a lot of the code is based off the same code you've been writing. Let's take a few more questions right here, and then I might start doing a little bit of review. We've done a lot of review, but I think we're just kind of getting ourselves set up for what the final will be like. So any other big questions? I'm going to disappear. I'm back. I've got all the mute buttons and the disappear buttons. Maybe that's why the volume keeps changing. Will the conceptual have only multiple choice, or how is it handled? Oh no, great question, Clay. Feel free to ask. The conceptual will have multiple choice, matching, true, false, and numeric entry. Multiple choice, matching, true, false, and numeric entry. And obviously, don't tell people what's on it. Don't be like, hey, such and such is on it. We do have a bunch of randomized questions, and it's meant to be as fair as possible. So there will be multiple choice, matching, and true, false. No essay. Oh, that's not fun to grade. That can't be auto-graded. No essay. See, now you're making me consider that. We didn't add those in, but I don't think we'll do that. We'd have to change what we're doing, and it would change the grading strategy for it. So there'll be no essay. It's more conceptual. It's conceptual knowledge. Your essay portions are done with the take-home. Where does the conceptual exam start? Like as far as topics? Right here. And did we include, wait a minute, I think we also included regularized regression on it. So let me see here, linear, yes. No, there's no market basket, perfect. Let's make this super clear. So it is, man, it's so long ago. There you go, great question right there. There are the topics for the final right there. All this right here. It is, I will say this, it is very much, with what I've written so far of it, it is literally, do you understand what you are doing? It's a lot of questions like, if this is this, then what would this do? Or like, why would you use this? It's very much like knowing how to make your models, knowing what each of these things do, which is kind of something I've been reinforcing. Like when we talk about a neural net, like what is a neural net? It's a bunch of perceptrons that are making predictions. And if we had hidden layers, the predictions make predictions to make predictions. And knowing each of these topics definitely at a deeper level than I just write in the code. So I want to very much make this clear that we have two ways of grading in this class. One, can you write code, which is very important, but two, do you know what the code is doing? So this class is not just about writing code. It's actually knowing what the code is doing and then being able to clearly explain to someone, well, this is what the tuning grid does. This is what the fit control does. This is why we have a holdout. This is why we have a validation. This is what overfitting means. This is what generalization is. This is what the estimated generalization error is. Let's see. Let's give a quick check. You guys ready? Okay, so let's have a vote. Let's do a Streamlab vote in here. Ready? So get ready to vote. Oops, I got the wrong thing up. Okay, so I'm gonna ask a question. Everyone's gonna get to vote on it. So we're gonna do a poll. The poll question is, which of these is related to estimated generalization error? Which of these? Don't put it in the chat yet. Don't put the answer yet. So which of these is related to estimated generalization error? Option 1, training, and that's a T vote. Option 2, validation. I misspelled it. There we go. Didn't validate. That's a V vote. Don't vote yet. Holdout is the last vote yet. Don't vote yet. And that's an H vote. Okay, let's click done. Let's go down here. Let's start the poll. Let's jump in. Okay, so which of these is related to estimated generalization error? Which of these is related? I'm going to give 500 Streamlab points to the first person who gets it right, but I won't say who gets it right. So you have to type vote. You have to do exclamation vote and then either T, V, or H. So you have to do like exclamation vote T or exclamation vote V or exclamation vote H. Which of these is related to estimated generalization? Let's see. Keep voting. Oh, it's close. Let's see what everyone says right here. Okay, you ready? Let's look at the points on this. You ready? We can close the poll and look how it did. I'm going to close the poll in 5, 4, 3, 2, 1. You guys are on a delay, so I'm going to close the poll now. All right, because there's like a 5-second latency delay. So let me complete the poll. Poll is closed. Wait, cannot complete? There we go. Poll is completed. So the answer to it, because we're going to go with what the class says, holdout is what won, but there's a key word. Who is the first person to say validation? Tyler, can you tell us what the key word is that means it's validation? What is the key word that would tell us it's the validation? What is the key word in what that question has that makes us know that it's the validation? What is the key word? And this is why I bring up a key topic like this, because I often see this. Don't worry if you got tricked by it. We tricked 53% of the class. This is why I bring this up. Estimated, you're right. Because the estimated is how we think it'll do on new data. Exactly right. Let's add Andrew as a mod right here. So I know your name. You're a mod. And so it's the estimated generalization error. So it's not how it actually generalizes to new data, which is the holdout. It is how we estimate it will generate to new data, which is done by the validation. So the key word right there is the estimated generalization error is done on the validation. The generalization error is done on the holdout because that is how it actually predicts on new data. Because holdout is new data to it. It's never done that. The estimate of how it will predict on new data is from the validation, and then the training creates the model. Does everyone understand that right here? I think that's one of the biggest gaps in knowledge I see. Don't worry if you were tricked by it. It's a key word that I think probably when I was learning this, I didn't even realize, like, oh, the validation creates the estimate of how we think it'll do on the holdout. How's everyone doing with that? Any questions? Don't worry, I tricked a bunch of people. Should we do another question right here? This is kind of how, don't worry, this is good practice. This is why we're doing this right now. Let's do another question, and let's do this one. Let's add, which of these cannot be used to predict a categorical Y? Which of these cannot be used to predict a categorical Y? And we'll put here, we'll do here partition models. Partition model for P. We'll do here support vector machine S. We'll do here linear regression with an LR. And then we'll do here, what's another model? Neural nets. For neural nets. Okay, add it right here. Okay, so let's do a check right here. Which of these cannot be used to predict a categorical Y? Which of these cannot be used to predict a categorical Y? Yeah, the Mewbuck still counts. I'm going to be super nice with these. See, that's too easy of one. I wanted to give you guys a... So let's see right here. Did I say I was going to get... I think I told the person I'd give them points. I told Tyler to give him points. So Tyler Young, let me give Tyler... I don't know if I can leave the screen. Tyler, don't let me forget to give you points. So everyone knows this right here. What's going on? What did Jake say? I didn't see it. So, Jake was like right off there right away. So everyone's getting this one. We'll close this poll. You guys got it. Linear regression is only a quantitative Y right here. So let's close the poll. And you guys got it. I need to figure out, there's a bunch of other things I can do with this. Like, there's mini games and stuff. But keep asking questions. Who has a question about the material? Let's open it up to questions right now. There's betting. Oh. We could try some betting. We could do that. We can take questions, or I could try the betting game. QQ straighten up, no outliers, plot doesn't thicken. Yes, because linear regression is for two quantitative variables. Aaron, 10 million points. QQ straighten up, no outliers, plot doesn't thicken is for quantitative, because Y has to be quantitative and X has to be quantitative. So it literally goes back to 1. It's betting with your Mewbucks. So I don't... Here, wait. Who is going to win? Here we go. Let's try this. We'll do a true false right here. You ready? So I have to... This is my first time doing this, so if I make a mistake, duration, minimum, maximum, we can only get up to 100 points. Reward multiplier times 2. Use timer. Okay, we don't want to... Yeah, sure, let's use timer. 100 seconds. Cool. And let's go here, and let's say true or false. Let's say using a fit control will always fit to AUC. So option 1, true, command T. Option 2, false. False. Okay. So it's exclamation point, exclamation bet T, exclamation bet F. But I think then you put your points after it. So let's see this. Feel free to ask questions about it. So it should... Oh, I haven't started the bet yet. Oh, okay, good. Start bet. Let's check this out. So using a fit control, we always fit... Using a fit control, we always fit to AUC. So let's talk about this right here. And so this should be started now. It's only got... Okay. So then you have to put in your points. So the first argument you put is true, and then you put your points. There you go. Andrew figured out the format right there. So you have to put your points afterwards. So you have to do exclamation mark bet, and then you have to use the points afterwards. So people are figuring out the format. So this is a bet format right here. And I think you can bet up to 100 points. You can bet up to 100 points. You can't bet 200. You can only bet 100. This is pretty cool if I get this going right here. So you've only got a moment more to bet. And then I'll talk about the answer to this. So I'm going to close it here in 5, 4, 3, 2, 1. I'm going to go over here and start closing it. Oh, it closes on its own time. Well, so you can probably change your answer. Everyone's betting now. Let's close the betting. Here, we'll do it. Close betting. Pick winner. And so let's see what it does when it picks the winner. Everyone should be getting their points right now. Yep, with 100% of the bets. Nice job. And then go ahead and check your points again. You should see 100 points. I gave away 1,435 loyalty points on that, or so it seems. But go ahead and check your points again and see if they went up. But please ask questions right now if you got them. We're just having a little bit of fun to end class. This is our last little fun day of class. The house never wins. Well, this time, you're right. The house does not win on this. So you can see if your points went way up. Tell me afterwards, after you check your points, to see if you saw a jump of like 100 points. So is everyone seeing that they have a jump in their points? So I don't know everyone's points beforehand. Maybe not. Was David the one who's at 420? So maybe it didn't give the points, which I don't know why it wouldn't, because I did the thing. Give them their points, Streamlabs. They earned them. I did a multiplier of 2. So I'm sorry if you didn't get your points. This is once again my first... I went up like 25. That's probably from talking. Yeah, it's probably from talking that you went up. There was supposed to be the amount you bet. Yeah, that's... Let me look at the bet thing again real quick, and feel free to ask questions. Let's talk about that concept first. Streamlabs comes second. I'll figure out what's going on with that, because that is my first time running that right there. So, this concept right here, I asked, the fit control always fits to AUC. No, 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 no. Can't do that. What it is your fit control right here. You can see a fit control probably in here somewhere. Where's a fit control? Show me fit control. You should know how each fit control kind of looks and why we use certain fit controls. I've probably passed it. Let's just fit control. There we go. Well, there's a fit control. And now here we go. What kind of variable are we going to be predicting right here? A quantitative or a categorical variable from this fit control. These are things you should know pretty instantaneously by looking at this fit control because one, you can write it out, or two, you can copy paste, but you should know what kind of variable we're predicting right here from this fit control. It's set up a certain way. The way fit control is set up controls what variable you're predicting. And so this one must be predicting based on a certain metric for a certain variable. Quantitative, you're right, exactly. And what metric will it try to optimize since it's predicting on quantitative? What metric will it try to minimize since it's predicting on quantitative? What metric will it try to minimize? And these are really good. Like this is, I'm trying to mimic what I'm writing for the final right now with, yep, RMSE, you got it. RMSE is root mean squared error, so it's going to minimize the RMSE. Great question, Ivy. The biggest thing right here, and let me go to the main part of it. The first time you see fit controls in this is under data mining 3, and I really like the way this is summarized right here. You'll notice right here, you've got your fit controls for quantitative. So we should put here quantitative, a little note. So when you set up your fit controls for quantitative, you can use no fit control right here. And you can also use k-fold cross-validation 5. And then you can change it to like k-fold repeated cross-validation. Now this will run the k-fold cross-validation 10 times with k-fold 5. So we're using k-fold 5 validation, cross-validation 5 times. Like you make 5 folds. If you remember how that works, you cut your data into 5 parts. You make your model, you make your model from these 4, and then you test your model on this one right here. You make your model on these 4, and then you test your model on this one, not to the next one, if you get what I'm saying. And so that's what k-fold cross-validation is. It's this, but repeated k-fold cross-validation just gets the estimate multiple times. And once again, this is your estimated generalization error. Once again, no estimate of the generalization error. So we're estimating the generalization error from the cross-validation. This is the V for validation right here. Now, if you go down here to this, you'll see that these are the categorical ones. So great question, Ivy. These are the categorical ones we're using right here because we can once again use nothing and use no cross-validation. That option was available to us also up here. This is no validation process through this. And then we see right here, we have the way of fitting on accuracy. So accuracy requires us to say class probs equals true. Class probs equals true is going to make it that it realizes it's a categorical variable. But there's an additional argument we need to add in. You'll see class probs equals true right here is also here, but now we're fitting on AUC. AUC is area under the ROC curve. So this is literally area under the ROC curve. So AUC and ROC are used kind of interchangeably because AUC literally stands for area under the receiver operator curve, which receiver operator curve is ROC. So if you want to get AUC as your tuning, as your kind of what you're fitting on, not your tuning parameters, don't think of it that way. This is how you're saying your model should optimize, and it's going to optimize the model on AUC. Does everyone understand what the fit control does? It's going to fit your model to optimize based on something. The method is the way it'll search for it, and then these parameters or these arguments right here control what it fits on. If you use this, you get accuracy, and accuracy is for categorical variables. If you use this, you get AUC, ROC, same thing. And if you don't do anything, you don't get anything. You don't do fit control. You don't get an estimated generalization error. And then up here, you would get from both of these, what would you get from both of these right here? What would both of these codes get you? Both of these codes are going to fit your model to tune it towards an optimized what? We said it earlier. Both of these, since they're quantitative, will optimize your model based on what? And does that make more sense, Ivy? We'll see what the chat will say it. Sorry we didn't get those points. RMSE, you got it. Check your points again. Maybe the points went up. I don't know if Streamlabs takes a moment. We'll see if the points went up. But you're right, it's RMSE. I feel like the latency is longer on YouTube these days. They might have changed it. Awesome, Ivy. Great question. Thank you so much. Continue to ask your questions. David had the 420, right? So we'll see if David's at like 440 or something, or if he's at like 540. So you guys can tell me Ah, no, I don't know why it didn't give the points, David. And I won't spend view activity bet. I picked the winners. Loyalty points. Ooh, wait. Oh, okay, wait. Okay, now do it. Okay. If there's an error, usually they say it's user operator error. So now, David and everyone else, now David, do your points again. Okay, so let's see here. So I'm gonna look at David's points. David had 440, and now let's see if David has 540 or like 640. Let's see what David's points are. I literally just had to click complete button, I think. Maybe not. Maybe not. I don't know. I completed it. Well, that's weird. I'll look into it. I don't know why. Name prime. What's that? Settings. Chat lines. Open message. Oh wait. Blank was winning option with blank amount of bets. Well, yeah, I thought it would work. I don't know. Maybe betting is broken. Be cool if it worked, but I don't see it working yet. What are additional questions that people have right now? Knowing how all the code works is super important. I can't state that enough. So knowing why we use certain things, knowing each different model, and understanding things like this tuning grid right here. This is just kind of a generalized tuning grid for you to see. I like this format right here. We've got here the tuning grid is going to be made by the expand grid. Can anyone tell me? This is something you should know instantaneously also. We're just doing quick rapid fire questions. How many different models will this tuning grid make? How many different models will this tuning grid look through? This is something you should know instantaneously, hopefully by now. 9 models. Will got it. Boom. Will, amazing work right there. We've made it right here, and there's 9 models. I'll show it a little bit better. 9 models, those are things we should know very quickly. I've put this on the test before, and then you can see the 9 models that makes. It's not really, it's just parameter 1, parameter 2, and we're just cycling them through values. How many models will this make now? How many models will this tuning grid make right here? And as I'm thinking about this, I'm really liking these questions. Like, I just want to copy paste this into the test because this is a great numeric entry question. Boom, Will got it, 30. And please, if you don't know how to do this, please say what's going on. How are you figuring this out? The answer is because there's 3 right here and there's 10 right here. And so it does all the combinations of them, and it makes all those different combinations of models from those parameters. And you do see the exponential growth. And just knowing how this code works, that if you just enter in, I do not like those non-spaces. So that's why we say coding looks a certain way. If you were to do something like this right here, oh, I will max someone out on extra credit if they can tell me how many models this makes. You're going to figure it out before me, maybe. How many models will this make? I think I got it. You're right, Nolan. You're maxed out. Nice job, Nolan. I guess I'll tell your teacher, but you're right because there's 26 letters in the alphabet right there. Will's also maxed out. We'll do Will and Nolan right there. So we got it. There are 780 different models, and great job. You guys know. Oh, I have the 10 next to letters. There's not 10 letters in the alphabet. So excellent job. You guys got it. And you can cheat down here because you can just do 3 times 10 by 26, and there you go. So you guys got it. You know what's going on with that. You know how this works, and it just permutates all the combinations. That's the key thing right here. So knowing what the expand grid does, it's literally like all the dials on your stove. Does anyone else think about it that way? It's like, I've got a dial here with 3 positions. I've got a dial here with 10 positions. And I've got a dial here with 26 positions. So you're trying to make this ultimate cake. All you're trying to do is make the best cake possible, best model possible. And when you're baking this cake, making your model, you have all these different settings you can try. You could turn the temperature up to this level. You could bake it for this long. You could put chocolate frosting on it, vanilla frosting on it. You could use, a store-bought cake box, or you could use your own home recipe. And you've got all these different things you can try. And so with all of these different things you can try, you're trying just to optimize it. You're trying to find the best possible way of doing it. Does that make sense to everybody right there? Does that make sense on how we kind of talk about these things and why the expand grid matters? The expand grid is the model grid you will search through for all the different types of models you will try. It is all the different types of models you will try. So it is just our different things we can make our cake with. It's not just like you could add this to the cake. What's so cool about model building is that we try every combination. That's what's crazy, is that you could do a crazy expand grid where you do like another. Now this expand grid is going to get even more crazy because now I'm going to go 1 through 100 here. And now if you look at this previous equation, now we're going to have this many models to try. Now that's going to be insanity and probably just crash my computer. Even a good computer is probably going to crash with that, like a really good computer. But you could try. You could try to let it run overnight. But usually what I would prefer to do is kind of look at if you've looked at previous videos when I did this, I would make my models over here, and then I would look through different like ones to see where I should narrow down the field. If anyone remembers, I think we still have it open. Let's talk about the importance of that. Are the names of the tuning parameters? Yes, they are. They're super important. Great question right there, John. They are super important. If you look at them, where do we have? We had tree-based models. So we should have a bunch in here. And yes. So I think, okay, this is the one I was doing. Perfect. Let's run a bunch of models here. As long as everything is good, we should run. Cool, it's running. Everything's running. And it's gonna get mad at me because these figures are too large. Okay. So the tuning parameter names, if you notice, this is the M try right here. M try is the amount of variables we'll be trying through each tree. So that's very important. You should know what M try is, knowing what the tuning parameters are. So I see the forest grid, and these are the number of parameters, or excuse me, the number of variables that'll be tried in each tree. So we're trying a tree with 2, 4, and 17 as we make these forests. So let's go ahead. We've got a whole bunch of different models in here right now, and we should be able to plot that forest. So let's plot, was it random forest? Are we missing random forest? Maybe we didn't save it. We didn't probably call it random forest. There's a tree. And where is my random forest? Forest fit. Ah, what's going on? Invalid graphic states. What's here? I want to do the other one real quick. Look at lab 8, lab 9. Support, yeah, I was plotting everything. There it is, plot neural net. There. Sometimes things don't want to run. Because we should be able to. Let's go back to here. I ran so much code so quickly, I'm like, what code did I run? Let's go right here, and there we've got the neural net, and you can plot the neural net. Neural net's not stored in here right now. Neural net takes a while. Let's reduce the size of the neural net. So let's reduce, this is the one we last did. So let's reduce the size of the neural net. Let's take the sequence down to this. Let's load up the data set. We've got our fit control in. We've got this. We go here. Boom. We got it. This one shouldn't take too long to do right here. If you notice, the names right here are the size. This is going to be the amount of hidden layers we're using. And then the decay is going to be the weighted decay for the coefficients in the models. So higher weighted decay is going to have them decay more, and hopefully we won't overfit because it's going to go less towards the coefficients. So now we can plot our neural net. Invalid graphic states. Someone told me how to fix this last time, and I don't know why I'm getting this right here. Someone said it last time in the thing, the invalid graphic state. You know what I might do? I might restart my R here in a second, because that'll usually fix it. But I'm getting an invalid graphic state error. Let me look at my plot. Let me just do plot. Okay, that's working. Look at what I did. And you know what's funny? Is I bet you. There's the force fit. Ah! Isn't that weird? You know, I don't know what, I just ran a plot I know would work. So what I did was, if you're wondering how Brian fixed it, I don't know how I fixed it, but I did fix it. So all I did was run a plot I knew would work, just plot the numbers 1 through 5. It plotted it, and then this invalid graphic state error right here fixed itself. Something's going on with the colors, it looks like these are colors of palettes. And so I think it's saying that this palette it's looking for right here, which was some of the colors for the neural net. So you'll look at the neural net's palette of colors. It's using this C palette, whatever that is, and that's going to control these colors right in here. So it's saying that that is null, so it doesn't exist. So something must have been masking it or doing something, which means it's also there. So sometimes your code just doesn't want to run, and that's one of those things where you're just like, I don't know what's going on, and then you fix it with a way you're like, I don't know how I fixed it, but I fixed it. So hopefully you don't run those same errors. But this did happen to us another time, and we were able to fix it, and we fixed it again. So, because I was like, why is that code not running? If you go back in the tape, you'll see my face being like, that's weird. So it's not fun when things are not working the way they should. But let's look at this right here. What you'll notice is how many models did I create? You can see how many models I created pretty quickly if you go right here, 1, 2, 3. And if you look right here, we have 1, 2, 3. So there's 3 dots going across this way because we used hidden units of 1, 3, and 5. And then we have here of the weighted decay values right there. So you can go back to the tuning grid and you can take a look. We've got 1, 2, 3, and I think it spaced them out a little bit more. We'll put them on 1, 3, 5. I'm a little bit confused by that right now. But we've got here, did not use the same one. There we go. Why is it doing 1 through 5? Why is it going to confuse me like that? It is plotting like that right there. Let me look. I have it stored as neural net. I will look into that. I'll see why it's doing that. Is it because I did this? No, that wouldn't be. Let's do this. Let's take a look. How's everyone doing? Are there big questions for the final? What questions do you have right now? What questions are there? I feel like my neural net is not properly plotting. Let me see here. Oh, you know why? Oh, I see it. Where is it? I see the issue. Okay, I see it. So I see the problem. Yeah, okay. How did I not see that? Someone else probably saw in the chat right now. It should be tune grid, right? It's got a capital G. 0, 2. Yeah, I think we'll definitely do. Was it not liking? Oh, I didn't put the comment, did I? I will do some review. We'll have review for the final. So what it's using right now is default parameters right here. So I guess I might have done this wrong in the review, or not in the review. But I was like, why are my parameters not being used? It's because I don't have in the argument for it to use the tune grid. Be very careful. It's very easy to forget to put in. And if you look right here, boom, now we got it. I was like, what is going on? So if you look right here, we have 1, 2, 3, 4, 5, because I put it on the vector 1 through 5, and we want to have higher accuracy. So it looks like this model right here is the one that's going to be chosen. So we have now chosen a weighted decay of this value right here, and we've chosen an accuracy of this one right here. The accuracy is, we've chosen the number of hidden units to be 5. Might overfit, we could look at that, but once again, I was missing one argument. The argument I was missing, and I confirmed this because I changed my tuning grid and it didn't change anything. You know what? Let's go crazy. Let's show what happens as we add in more hidden layers. This is a bad idea. It's a horrible idea. I'm wondering what's going to happen with 100 hidden layers to it. So we've added now in 100 hidden layers to this neural net. With 100 hidden layers, what will this neural net do? How well will this neural net do? And with 100 hidden layers, did it actually finish? Oh, it got mad. It got some warnings. Oh, wow. Look at that. That's so cool. It actually, the model says it will do way worse. So this is a horrible idea. If you look at this right here, the model, all of a sudden, both of these just get completely horrible. And apparently it knows that it just can't do better. So this is we did 1, 10, and 100. So I'm looking here. I don't know why we'd have, that should be 1, and that should be 10, and that should be 100 right there. That's the weighted decay. Excuse me. So the 100, is it not on here, or is it overlapping? I think the 100 might be overlapping one of these right here because the changes in hidden layers. So that was a horrible idea. Wouldn't want to do that. Let's go here 5 and go to 10 and go to 15. So this will be the colors of the lines right here. So the colors of the lines are the hidden layers. I think we just had an overlapping color right there because we couldn't see the green line. So let's go ahead and take a look at what we have with this neural net right here and just get a quick look at it. This is something I think I missed earlier and never understood. What's the difference between AUC and accuracy, and why is it better to use it? Yes. Let's go over that next right here, Andrew. That's a big concept for the final. So that's a huge concept. So I'm going to take a look at this neural net right here just to see how it looks, and then I'm going to review that with you, Andrew, right here. So accuracy, well, it did it. We'll come again. And it looks like, which one are here? The hidden units. So I must have flipped my things before. We are doing better with 15. I don't know. We'll see. These are all very similar, though, I'm sure. Okay, so Andrew asked a really great question. What's the difference between AUC, accuracy, and all of these things? Because when we talk about accuracy, can anyone in the chat define for me, without looking at anything, what accuracy means? What is accuracy and what does it mean? What is the accuracy of the model? What is the accuracy of a model? Like if you had to tell your boss, like your boss says, what is the accuracy of the model? What does that mean? So pause the video here and see if you can write a definition for accuracy that you could tell your boss. Like without being like, well, we have to look at when the true class is, when the yes class is equal to the yes class and the no class is equal to the no class. That's actually an answer right there. It's the percent of time the yes class equals the yes class and the no class equals the no class. Yeah, exactly. Christian, you're right. It's like what percent of the time does it get something right? So that's because that's the percent of time the yes class is equal to the yes class and the no class is equal to the no class. So you could literally do a sum of, and what I'm saying is the predicted yes is equal to the actual yes. The predicted no is equal to the actual no. Does that make sense right there, Andrew? Accuracy is the percent of time the predicted yes is equal to the actual yes plus the percent of time the predicted no is equal to the actual no. But Christian gave a really good kind of just telling your boss what the answer is. It's the percent of time that we can accurately predict what something is from our model. So it's like if you're predicting if someone will be successful in the majors, your accuracy would be you predict yes when it should be yes, and you predict no when it should be no. So it's how good you are at making predictions, how accurate you are. How many times out of all the predictions is the model correct with this prediction? Boom, Andrew, amazing answer right there. It's a really good way to sum it up. Like how many times its yes and no predictions are correct to the truth, because that's what we care about, the truth. How often does our model accurately give the right prediction for what the truth is? That's what accuracy is. It's literally just how often does our model get it right? Does that make sense now what accuracy is? It's literally like my model is accurate 90% of the time. So 90% of the times the prediction it gives matches the actual thing it is. So that's what accuracy is. And then awesome. So what is AUC? AUC is the really complicated one. And so we've done quite a few graphics on it. I might draw it out here again. So we'll do a really quick graphic on it. It's a good way to kind of end. So we have here, this is going to be what people actually are. So people actually are, they're going to actually buy our product or not buy our product. Does that make sense? So people are going to buy our product or not buy our product. So we have right here the what people actually are. Let's put up here actual. And let's put up here predicted. Now, here's a very important thing you have to know about predicting categorical variables. What will we be predicting here? Yes or no? Will we be predicting yes or no? You have to know which one you're predicting. We'll be predicting yes because in logistic, the level of interest is last. And that's just the thing we say to help us remember it. The level that is last is the one we are predicting. So we're predicting yes. So all of these probabilities right here, and I'm putting them in order. They don't have to be in order, but makes life easier for the moment. All of these probabilities right here are going to be the probabilities we would assign. Can someone compute for me the accuracy of the model right now? Can someone compute for me the accuracy of this model? Correct, 3/5, because this one right here is correct, these are correct, and these are wrong. Can anyone compute for me the AUC of this model? Now, even I have to think what the AUC is. Let me think. So it's what percent of the AUC stands for what percent of the time does the yes class get a higher probability than the no class? So we have to figure out what percent of the time the yes class gets a higher probability than the no class. And I think the AUC is actually really high. The AUC is going to be 5/6, I think. So it's what percent of the time does the yes class get a higher probability than the no class is what the AUC is. So the accuracy is 3/5, like 60% of the time the model is accurate, but the yes class receives a higher probability than the no class 5 out of 6 times. And we can see this right here with the following. Let's use space pen. What percent of the time does this yes get a higher probability than these no's? How many out of how many times does that yes get a higher probability than those no's? So you have to look at this yes right here, and you have to look at its related no's, which are these. What percent of the time does this yes get a higher probability than those no's? That yes gets a higher probability than those no's. What percent of the time? How many out of how many times? Does that yes get a higher probability than that no? 3 out of 3. You're right, Caleb. You got it. Nice work. And then what percent of the time does this yes get a higher probability than these no's? What percent of the time does this yes get a higher probability than these no's? 2 out of 3. Bingo. So that'd be 5 out of 6 right there. I believe. I'm just doing the math in my head. It would be 5 out of 6. So 5 out of 6 times. We can also plot this right here. You have to go here, and you have to move through your true negatives and your true positives. So there's the true positives right here, and the true negatives down here, and you have 3 true negatives to move through. Here's your 50-50 line of 50%, which you definitely hope to beat. So we spaceman for that. Spaceman. So when we move through this, we should see that we get our first true positive right here, and then we get a true negative, and then we get a true positive, and then we get the last 2 true negatives. And if you divide this up, if you make this into a grid, can you tell me what percent of area I've shaded? This is probably I think this really helps me see the AUC and see what it's been. Can you tell me what percent of area I've shaded under that grid? It's 5, 6, yeah. I might do a chart like this. I don't know. I might have you calculate it. I do think, as I'm writing more and more of this, I do think this is very likely. I don't think it's too hard to calculate when you understand what's going on. And this is a very small example to show that you know how to do AUC. And then kind of, I like the visual. If you guys can't tell, I've been trying to use this example more. Has this helped people understand that this is how we calculate the AUC? I'm sorry, one time I put the wrong thing below there. I do make mistakes every once in a while. But you move through your true negatives or your true positives. And if you notice, the pathway I took is relative to the way this is. Let me make sure I did it correctly. Yes. This is a true positive. Let's put in a different color right here. So this right here is a true positive. True positive, true negative, true positive, true negative, true negative. Awesome, Joel. I know you got to see it multiple times, and literally I have to teach it multiple times to like get better at teaching it. So you guys have helped me a lot this semester. A lot of great questions on AUC. I mean, I've done it before. I can tell you the definition of it, but to be able to like come up with these examples, yeah. So the 5, 6, why it's 5, 6, you can see graphically why it's 5, 6 right here. But I know, like, look at the graphic. It's 5, 6 of the graphic because you've got 6 sections. And it's 5, 6. No, Nolan, great question. The reason it's 5, 6 is what you're saying with 5, 6 is that 5 out of 6 times the yes class gets a higher probability than the no class. So I want you to look at this probability right here for the yes class right here. And I want you to tell me how many times is it higher than the no class's probabilities? How many times, blank out of blank times, that probability is higher than the no class's probabilities? Blank out of blank times, that yes class. Oh, then I'll explain that here in a second, Andrew. I'll explain that here in just a moment. 3 out of 3. Okay, then I want you to look at this yes class, because remember, we're only saying what percent of the time does the yes class get a higher probability than the no class. With this yes class, what percent of the time does this yes class get a higher probability than the no classes? What percent of the time does this yes class get a higher probability than the no classes? Oh, you see it. Aha. Add them together, and what do you get? You get 5, 6 right there. So with this right here, you can see, yep. And I guess with that, well, you would average them. You wouldn't add them. You wouldn't. I did say add, and I was like, wait a minute here. You would average them technically. So you would average them, and then think about that'd be 2.5 thirds, and then to change the decimal back to it, you do 5, 6. So you actually average them because it's like on average, what percent of the time does the yes class get a higher probability than the no class? It's not one specific yes class. It's on average, what percent of the time does the yes classes get a higher probability than the no classes? You're welcome, Nolan. Great question right there. So what we like to do, just walk through it. Don't worry. Everyone's been here a lot, and sometimes you got to re-ask it. You'll be like, well, why is it? What is it? And it's a great question. So then Andrew asks, like, so why is this better? What is AUC going to focus on doing? What is AUC's primary goal when we create our list of things? Like, what is AUC's primary goal? Like, what will really help AUC to put what's where? Ordering. Exactly, Zach, 100% right there. Zach is totally right. It's ordering. Putting the probabilities in, putting the yes class at the very top. AUC, like, how much would if we look at something right here, how much would, so we've got here actual, and let's go to prediction. Okay. This is no, yes, yes. Okay, and then we'll go right here and we'll do this. 51. You can run through this example. It's a seventh. Sevenths are not fun, but sure. So you can figure this one out on your own if you like. This will be ending here soon, but loud honking outside. There we go. Okay. So this model right here, its accuracy is pretty easy to compute, but we can actually do its AUC pretty quickly. If you know the tricks for AUC, this AUC right here, it's actually not that bad. Oh, I think I know what the AUC is. I got it already. Who here can do the AUC? I'll max you on extra credit if you can do the AUC, because it's very easy the way it's ordered. I thought it'd be harder, but not too bad to do the AUC on this one. I'll draw the graphic while you guys are figuring out the AUC. So we got to go here. True positives here. Not 1, not 0. Not 0. Nope. Does anyone know the AUC? Joel, you're right. Nice job, Joel. You got it. You guys got it. And look at that. 9/12 is 3/4. There it is right there. You guys got it. Nice job. That's it. And if you notice, the yes class, just by the way it's ordered, and then what is the accuracy of this model? There's 7 observations. What is the accuracy of this model? What is the accuracy of this model? What is the accuracy of this model? The accuracy of the model. Yep, Joel's right. 6/7 is the accuracy. Changing this right here. What is the accuracy now and what is the AUC now? Changing this right here. What is the accuracy and what is the AUC? If I change that, what is the accuracy and what is the AUC? And then you would technically divide by 3, Yulia. After you do 3/4 times 3, you would divide by 3. Because it's like the average of like how often the yes class gets a higher probability than the no class. So you would divide by 3 technically. And so what is the accuracy now? What is the AUC now? And hint, I didn't change the order. So if you look at this, and this kind of, Andrew, maybe highlights, if someone said to give to me the top 4 people, AUC would stay the same. The top 4 would still be this. And then AUC is 9/12 and accuracy is 5/7. Boom, Caleb, you got it. AUC stays the same. Accuracy is going to dip 1. Accuracy is going to take a hit right here. Accuracy is now going to have this one wrong and this one wrong. So accuracy takes a hit on those 2 right there. So this is not correct. Due to the probability, this is not correct. Yep. So did this help out with this example right here, Andrew? Like knowing and seeing the graphics. Maybe I like drawing those graphics now for some reason. And these are the true negatives right here. Yay. Good graphic. Just know how it works, know how it looks. And then you could add in your 50/50 line, which would go something like that. Something like that. Can you show AUC here with the arrows? You do. Oh, yeah. This one is lower than this one right here. So this one is 3/4 accurate. So that yes is properly ordered 3 out of 4 times. This yes is properly ordered 3 out of 4 times. This yes right here is properly ordered 3 out of 4 times. So as Julia was pointing out, that is 3 out of 4 times 3 out of 4 because it's 3 times, but then you would divide by 3. So in truth, what you're doing is the mathematical equation for this would be 3/4 plus 3/4 plus 3/4. And then you would divide this by 3 because it's on average. So that would be the mathematical equation for it. You're welcome, Joel. There's the equation right there. So you would do this right here, and that's the AUC. And we see that 3/4 divided by 3 is just going to be 3/4. So 3/4 plus 3/4 plus 3/4 divided by 3 is 3/4. So because there's 3 of them, you remember 3. So the whole thing just equals up to. True negatives went away. That's got it. Can you explain the 6/7 accuracy one more time? Sure. And so we changed it. Let me remove it's no longer 6/7 accuracy. The accuracy is just going to be so now it's 6/7 again. The reason you know it is because this one had a high probability of being yes and it was actually no. That's a miss. That's an incorrect prediction. This has an over 50% and it was predicted yes. That's correct. It'd be predicted yes because its probability is over 50%. This would be predicted yes. This would be predicted yes. This would be predicted no. This would be predicted no. This would be predicted no. The only one right here that was predicted incorrectly was the top one because it had a 98% probability of being predicted yes. This one right here is going to be, I'm going to change it to this, and now we would predict it to be no. So here we're going to predict this one to be no now, and that is an incorrect prediction. So now it's 5/7. I think that's got it. Amazing questions. Does that make more sense, Julia? Now the accuracy is 5/7. So now I'm showing the accuracy right here. So just depending on the probabilities, then we would make the predictions. You're welcome, Julia. Great questions. Please fill out the TN voice. Give your comments. Tell us what you think about this, especially the new online format. I'm going to head off and get ready for next class. But thank you all very much. It's been fun. We will do reviews probably this weekend. Stay tuned, and we will do more. I'll see everybody soon. Bye.